This is question number 36 of GATE 2017 chemical engineering paper related, and the question is related to process fluid mechanics subject. The following table provides 4 sets of fanning friction factor data for different values of Reynolds number and roughness factor K by D. Which of the above friction factor data is correct? So over here in this question, we have been given a table in which we have been given this Reynolds number, and corresponding to that Reynolds number, we have been given this roughness factor K by D. And for each of this Reynolds number and roughness factor, we have been given this calculated fanning friction factor for this 4 sets: set 1, set 2, set 3, set 4, and we have to find which one of the following 4 sets is the correct. So we have this plot of friction factor or the fanning friction factor F versus Reynolds number. From that we can see that if the Reynolds number is less than 2100, that implies the flow is laminar flow, and when the flow is laminar flow, the friction factor versus Reynolds number line will be a straight line, and that we can write it as F is equal to 16 upon NRE. Then there will be a critical region between the Reynolds number 2100 and 4000, and then we will be having a turbulent region. Now in turbulent region and as well as critical region, we can see that with increase in Reynolds number, the value of the friction factor will decrease, and also friction factor will depend on the roughness factor, that is the ratio of K by D. And we can say that the friction factor will increase as the roughness increase. That is as K by D increases, the ratio increases, the friction factor will keep on increasing. So using this information, we will solve the questions. So first of all, we can use this information of laminar flow. So laminar flow is characterized by the Reynolds number less than 2100. So for this first and second case, the Reynolds number is less than 2100. That is, we can see that this side is laminar flow and this part is turbulent flow. Now for laminar flow, we can calculate the fanning friction factor as 16 upon NRE. So it will be for this case. So for laminar flow, this roughness factor won't play much role. So we can simply use this correlation and calculate the friction factor as. So for Reynolds number of 100, we can write that F will be 16 upon 100, that is 0.16. For Reynolds number of 1000, that is this point, we can calculate the friction factor as 16 upon 1000, that is 0.016. Now from the given 4 options, we can see that for laminar flow, in the set 1, we have been given that the fanning friction factor is 0.16 for Reynolds number of 100, and for Reynolds number of 1000, the fanning friction is 0.016. That is, this option can be correct depending on if these two are correct. Now for set 2, we can see that the friction factor for Reynolds number of 100 is 0.016. That is incorrect. So this set 2 is incorrect. And for set 3, again the friction factor are 0.16 and 0.016. That is what we have calculated. So this can be correct depending on these two values. Now set 4, the friction factor is not this 0.16 on 0.016. So that is it. The set 4 is also is incorrect answer. So right now we have 2 candidates for the correct answer, that is set 1 and set 3. That is any one of 2 can be correct. So now we will be using the other information based on this turbulent flow criteria. That is, as K by D or the roughness factor increases, the friction factor should also increase. So for this 10 raised to 5 Reynolds number, we have been given the roughness factor as 0. That is, the pipe is very smooth. And as we increase the roughness factor to 0.001, ideally the friction factor should also increase. So if the friction factor increases, that implies that that corresponding set will be correct answer. Now for set 1 and set 3, we can see the value of fanning friction factor in the table, and For set 1, for Reynolds number of 10 raised to 5, the friction factor is 16 into 10 raised to minus 5, and again for the same Reynolds number of 10 raised to 5 for different friction factor, that is 0.001, we have been again given the friction factor as the same, that is 16 to 10 raised to minus 4. That is with change in the roughness factor, that is K, ratio of K by D. The friction factor is not changing in this case. However, from this plot, the friction factor should change as we increase the roughness factor. That is, set 1 is an incorrect answer because this wasn't changing. Now, if we take a look on this set 2, set 3, we can see that the friction factor is increasing as we increase the roughness factor from 0 to 0.01 for the same Reynolds number. That is, set 3 is the correct answer. That is, from the given 4 options, the option set 3 is the correct answer, because in set 1 we saw the set 1 we rejected because the friction factor was not changing with respect to Reynolds number for constant Reynolds number. In set 2, the calculated friction factor for the laminar flow for both this Reynolds number were incorrect. And in set 4, again the calculated friction factor for the given Reynolds number were incorrect. That is why we rejected the set 1, set 2, and set 4 as the correct answers. So from the given options, we can select option C, that is set 3, as the correct answer.